Hi, hi everyone. Welcome to this presentation. Thank you for being here, and of course, thanks for the invitation to this nice conference. I hope I will be able to contribute at some other time in the future. So, in this presentation, I'm going to talk about the process of creating Burp extensions. And my name is Antonio Lara, although I usually go under the name of Doc. Alright, a little bit about me before I start. I actually come from a physics background, didn't study computer science formally, although later I transitioned into the IT world and I have been working in cybersecurity for around 6 or 7 years. I like to automate stuff, and that is a manifestation of that is Burp extensions, because you can use them to automate a lot of your everyday work. And I hope that I will be able to transfer to you this interest in automation and how it can save you a lot of time. I am the author of a Burp extension that you can find in the App Store, called Header Issue Reporter. It's something that I created for my own use during my previous job and saved me a lot of hours. So I encourage you to give it a try if you are a pen tester or a bug bounty hunter. And give it a try. I'm sure it will save you a lot of manual work and a lot of hours. Um, Feel free also to contact me on LinkedIn or to check my repo where you can find this extension and some other projects. For some reason, Portswigger decided to um, set my extension as a pro extension. I don't have any participation in that. They took that decision. I'm really not sure about the implications. And also, I can tell you that I don't make a single dollar out of it, so I don't know who is profiting. But if you take the extension directly from my GitHub, you can use it free of charge. Whereas if you wanted to use it from the App Store, I think you need the pro version of Burp, but it's not necessary. You can use it on the community version, as I will be showing in some demos. Alright, Burp Extender. So Burp has a set of APIs that allow us to interact programmatically with its internal components and use them in a custom way. Not everything is accessible through this API, of course, because in the end, Burp is a closed source tool. So it's normal that we don't have access to all its internal utilities either, but there is a lot that we can use from it. This is how this talk is going to be structured. I will give a brief introduction to Burp Extender, then talk about object-oriented programming, which is something essential if we want to create our own extensions, although I'm aware that many people in cybersecurity don't like to code, but in this case it's necessary, and I think it's something worthwhile anyway to learn to code. Then we will have a look at the Burp API itself and the two versions that there are, and I will justify why I am using the old one. And then we will go through some examples where I will show you what it takes to create the most basic possible extension, as well as complicated with more advanced features like graphics. And finally, I will give some tips if you are planning to submit your own extension to the App Store. Alright, if we look inside Burp, which of course I assume that everyone knows what it is because it's probably the most used tool in web app pen testing, there is this tab for Burp Extender, and inside of it there is this other sub tab called App Store. I'm pointing with my mouse. I'm not sure if it's possible to see, but here you see it's highlighted, the App Store tab, and there you can find all the extensions that have been accepted by Portswigger. You can sort them by popularity and by rating. I'm not really sure where those metrics come from, but there are so many by now that many of them are probably very useful, but people just don't know about them and keep using the same ones all the time, which makes sense on the other hand. All right. Um, this is the main tab or sub-tab under the extender tab, and here you can see the extensions that you have loaded into Burp, the ones that are active, or you can load many and then unload them but still have them in this list, and you can simply load them by clicking on the checkbox. Under this list we have another set of sub-tabs called details, output, and errors. This gets populated by the extension itself, either when it loads, or if it produces any output, or if it generates some errors due to some problems, either when it loads or when it's running, so it's useful for debugging. Now, I will be showing examples of how to write extensions in Python. We have three options for Burp Extender. We can create extensions either in Java, in Python, or in Ruby. Since Python is the most popular language in cybersecurity, that's what I will be showing, but nothing keeps you from using these other languages. In fact, the whole Burp suite is written in Java, and the integration with Java is like the most natural. And one way that you can see that is that you don't need to load any external dependencies for Java extensions, and also they load the fastest. But since Python is easier to write, that's what we will use. So if you want to use Python extensions, what you actually need is Jython, which is the Java implementation of Python. Python is originally implemented in C programming language, so that is the regular Python or C Python. But then there is this Jython version, which some people have decided to create using Java as the main language to code the Python interpreter. This has the advantage that is able to load and interact with other Java code and libraries easily, and it's a JVM language. The problem is that it's a bit outdated. There is no equivalent to the Python 3 version, so Jython for the moment is stuck on the Python 2.7.3 version. And although there are some conversations about creating a Python 3 equivalent in Java, it's still not happening for the moment. It likely will never happen. So we are, for example, limited to using Python 2 syntax. In any case, in this link you can download the jar file for the Jython standalone interpreter, and that's what you need to get to download to your computer, and then point to that file in this extensions configuration that you can see in the screen. There you select your path to the jar file, and that's it, you are ready to go. Now, let's talk some object-oriented programming. I will only touch on the basics, so it can go much deeper. Object-oriented programming is a style of programming that represents things as objects from the real world. These objects can have properties and methods. Methods are basically functions inside the objects which can perform actions, and the properties are just variables which have different values of different types. Object-oriented programming is probably the most used paradigm everywhere because it makes sense. It's logical for the way we understand the world to represent things. And these are some typical terms or words that you will hear when you learn about object-oriented programming. Things like class, instance or object, properties, methods, inheritance, polymorphism, encapsulation. So these things can get complex. Many people do that for a living, and yeah, my intention is not that everyone will be an expert after this, but it's necessary to understand some concepts in order to write Burp extensions because it uses from the beginning to the end. So let's go. I hope it's understood. For that, I will use some nerdy examples. For example, some robots from Star Wars and how they could be represented in a program. So, first thing we need to understand is what is a class and what is an instance. Um, uh, if you already know all these, feel free to skip ahead. It's going to take me like 15 minutes to finish this part. After that, we will apply it to Burp. So a class is a blueprint that specifies how something, some object will be built. But the blueprint itself doesn't represent any real object existing in the real world. It's just a set of instructions of how to build new objects. Building an actual object from a blueprint, from a class, is called instantiation. And when you instantiate an object, you can call that object an instance of the class, or you can just call it an object. And in Python, the way to instantiate is with this simple line that I have here in green color. So first look at the piece of code on top in the center. It's a Python file called atat.py, and inside it there is a class definition called atat in capital letters. Under this class there is a property called head, and there is a method called init. Actually, the indentation is wrong, sorry for that. Head and the definition of the function should be at the same indentation level. So we can have any variables that we want here as parameters, but the init method is a special method called the constructor, and it's something that will be executed every time an object is instantiated. So it will create these new variables. We can see the self keyword, and it's a way of the object to know that it's referring to its own properties. So we have something like self.legs equals 4. It means that that object will have 4 legs when it's created. And maybe at some other point we create a different object which has 5 legs, and then changing that after creation doesn't change the 4 legs of the first object. So by using self, you isolate this object from the rest. Some other languages like Java use the this keyword instead of self. And finally, the way to instantiate objects, as I said, it's here, and you define a new variable that will be the placeholder for the new object, and you call the name of the class with parentheses behind, and that's the way to instantiate a new class. It's like calling the init method. All of its contents will be executed at this point, and we will have in this new variable AT81 the new object. Now this object exists in memory as long as it's not deleted or the program is not ended, and we can add new attributes to it, or we can modify the ones that already exist. The way to do it is basically to access these new properties with the dot operator and the name of the property later, and simply we can change the value or create a new one if it doesn't exist yet. So you can do this in real time in the Python console, and by creating new attributes, as you can see here, you would observe the following. So in Python you have the dir function, and it will return everything that is contained inside the object that you pass between parentheses as an argument or as a parameter. So we see that after some of these transformations that we did here, now the 8081 instance has these new properties inside: the armor, the color, if it's dead, the number of legs, whatever. Whereas if we look on the second command at the contents of the class itself, we can only see the head property, which is to be expected because it's the only property that was defined in the class definition. The rest were defined later once the object has been created, and they were defined in real time on the object itself, not the class. So that's the difference between object properties and class properties. So now let's talk about methods. Methods are functions that you define inside the class, and you can put anything you want inside, and you can, for example, use them to update the values of the variables that belong to that object, irrespective of what the class has. So we discussed briefly some slides ago the concept of encapsulation, and it means that you don't access internal variables of an object directly from the outside, but only through getter and setter methods. That's one of the usefulness of methods. It prevents that someone can access this internal information and modify it in an uncontrolled way. So Python doesn't have the, at least not so clearly defined, the concept of access modifiers. But for example, in Java, you find things like public, private, protected, which dictates what can access an internal property of an object. We are not going to care much about that because in the end we expect our extensions to be used only by ourselves or by the users who want to use them, and it's not so relevant to have these considerations in mind. But if you were doing some serious program that could I don't know, move a lot of money or something, then you would need to take care about these things, about these access modifiers, for example. So here we have defined a couple of methods besides the init method inside the class, and that means that all the objects that will have this will be instantiated from this class will also possess these two methods. We have a walk method and a fire method, and we see how every time they execute they modify the battery and also, in the case of walk, the position, which are two internal variables of these objects. Yeah, so every object will have it, and as you can see in the definition, there is the self argument in both methods. In object-oriented programming in Python, by default you need to pass or to have as a first argument the self argument on every method, but then when you invoke the method you don't need to use it. In fact, you don't have to use it. You get an error if you do, because it's passed implicitly. So if you pass it explicitly, you will be passing one more argument than necessary, and there will be an error. But this is necessary to do. It's like that. It's a Python standard. So now we have inheritance. Inheritance is very useful to avoid code duplication, but also you need to be careful of how you implement it because it can end up being a mess. So when many objects are going to share some similarities but also are going to have some differences, inheritance makes sense to use. You can define a base class or parent class which will have the common properties to all the methods, to all the instances, and then you define other more specific instances that will inherit the properties from the parent class and then will have their own properties. Doing that, you avoid repeating the same definition of variables and methods that will be common to all the classes, resulting in much cleaner code. For example, in here we have a class called ATXX and has things that are common to all these robots. So for example, we have the head and the position, and we have this wait method. But then every robot will have some specific features that are unique and the others don't have, like the number of legs or the armor. So for that, we instantiate each of these by inheriting from the parent class. And the way to do it is in the definition of the three lower classes, we pass the name of the first class between parentheses. That's the Python way of indicating that we are instantiating from the first class. And then inside the init method of each of these classes, there is a call to a super method, and that indicates that it's first running the init method, the constructor method of the parent class, and then some other stuff happens later. But first, the parent class constructor is evaluated, which ensures that each of the classes will have these methods and properties, and then we can override some of them with the values that the specific robots will have. As you can see, that happens later, still inside the init method. So this is basically to give you an idea of how simple inheritance and how logical can be in coding examples, but then in real world it can really become a mess, because at the time of doing it everything makes sense, but after some months go by and you need to review a huge tree of inheritances, it can be very difficult to understand what's going on. So it's useful, but sometimes it could be better to have some duplication if it makes things more clear. Now we need to look at the concept of abstract classes, and this is necessary to understand how to use the Burp API. So first of all, Burp APIs are what are called Java interfaces. So we need to understand the difference between the interface and an abstract class. They are similar things but not exactly the same. So an abstract class is a class that at least has an abstract method, and an abstract method is a method that you define but don't implement any logic inside it. You just say that that method should be there. But then the logic will only happen in the children that inherit from that. So for example, here in this example we have, actually I'm not sure if this is correct because this is a Java example and we are returning a 0.0 float. Maybe that shouldn't even be there for a abstract class. I'm not sure right now, but it doesn't matter. But as you can see, we are extending this shape class. Extend is the keyword in Java to use inheritance. And we are implementing the logic behind this area method. Alright, yeah, this is what I wanted to show. So this is not an abstract class because again we are putting some logic inside, but if we want to have an abstract class, as you can see here on the left, the first class turns into what's on the bottom, and you can see now that we use the abstract keyword in the area method definition, and the method itself is empty. There is not even a return statement. Whereas on the right, we are transforming the way the child class and how to use it to extend or to inherit from the abstract class on the left. So to do that, again, you use extends. There is no change in there. But now we use this override annotation to indicate that we are overriding this behavior of the abstract class. So there is this concept of multiple inheritance, and it means that a class can inherit from different classes at the same time in parallel. And for historical reasons and some problems and confusions that can arise from here, historically Java didn't include this possibility of multiple inheritance. So you want to inherit something, if you want to use an object that inherits from many different other objects, you need to do it in series, like in a chain of inheritance, as you can see here on the left side. And you could say that you want to benefit somehow from multiple inheritance. Then in Java you cannot do it directly with abstract classes, but you can use multiple inheritance from what is called interfaces. So interfaces are a special case of abstract classes where no methods are implemented. There is no logic for any method. There is only logic for there is no logic. You have as many abstract methods as you want, but none of them can have any logic. They all need to be empty, and when you implement this interface, you need to implement all of the methods. There can be no single method that is left unimplemented. Also, the keyword changes. Instead of using extends, you need to use implements if you are dealing with interfaces. So that's the difference between the two. And as we will see, the Burp API consists of a bunch of interfaces. So first, some clarification about the Burp API. There are actually two Burp APIs. There is the currently supported one, or we could say encouraged by Portswigger, and there is the old one, the legacy one. The new one is called Montoya. It's from 2022, if I'm not wrong, and previously there was the Beaner. So as I show here, I have a Burp instance here, and inside of the extensions tab you have this API tab, and here you have all the contents of the Montoya API. So you can unfold any of these, and here you see the contents of these interfaces. All of them are Java interfaces, so this is Java language, and you can see in all of them that it says public interface whatever. So interface is the keyword here. I will go into more details later. In the past, there you used to have the Beaner interface, but now it's being not deprecated because it's still backwards compatible, but it's not in the user interface of Burp anymore. You need to go to the Portswigger repo and you will find it there in this link that I have here on the slide. So this that you can see at the bottom of the screen is a screenshot from the Portswigger website, and it's a justification or an encouragement to users to start using the new Montoya API instead of the old one. So you can see here on the second last line, it says from Burp Suite 2022.9.5, you have this here available. And well, in my opinion, this is not such a good idea to use, at least from the point of view of someone who is already conditioned to use the Beaner API, which for example is what I used to write my own extension, and that most extensions really use, at least the famous ones, the ones that have been around for several years and that all of us use, are implemented in the old API. Maybe someone is taking the effort to translate it into the new one, but I doubt it. It's completely different. It has nothing to do, nothing that you know from the old API will be useful for you. You need to relearn everything, and to rewrite everything, to me, it would be just a pain. So I wouldn't do it. I wouldn't change it. And I don't see why anyone would put the effort into doing it, unless there is a good reason, like some functionality that was missing in the old API and is available in the new one. But if extensions like Turbo Intruder or Authorize don't need that, then I don't know what kind of extension can need this new functionality. So again, anyone can learn the one they want. You will have full support with Montoya, but I doubt that it's worth the effort when it's also not so well documented. Well, I have to say that in general, the Burp extension development process is not very well documented. It's not so easy to find clear information, and I hope to fill that gap with this presentation. But having said that, I will focus only on the Beaner API because it's the one that I know, and it's the one that you will most likely face if you want to modify, for example, existing extensions. And at least the way of working with the APIs will be similar in the Montoya, so even if you decide to go with Montoya, this presentation could be useful. Now, let's start with some examples of simple extensions. This that you can see here is the simplest extension that you can have. It's an extension that is loaded without any errors by Burp, and that has a name and that prints some output to the console. So it's what I have called demo 1. You will have access to all these demos in my repository. You can go back to the first page to recall what's the name of my repository, and you can find it there. So I have this Burp here, and this is well, let's remove it because I already had loaded it. And if you want to add a new one, I already have here my Python standalone configured, so it will work if I load a Python extension. If not, I would get an error. But here you need to select Python and then select the file that you want to run, in this case demo1. So go next, and it takes a while to load. It's slower in Python. And what do we have here? We have an error. All right. Apologies. It's a very big font. I hope you can read it. So what's the error here? It says name error, name burp extender is not defined. Let me show you the source code that I am loading. It's here, and if you notice, there is a 1 here. I modified the name, so it's a burp extender 1. That is causing the error. This class is looked for by Burp, and it needs to be called exactly burp extender. If you call it something different, and if there is no burp extender class, it will fail. So I saved the file, and I'm going to reload it, and now the error should be gone. To reload something, you don't need to remove it, and to add it again, you can click here, but if you press Control while you click, it doesn't ask you for confirmation. It's much more convenient. So now it worked, and as you see, we have the hello output here in the output window. We have no errors, and the extension has gotten the name that we specified here. So here we have specified the name and the output, the two things that we can see. Again, here you have access to this output window, and you see the same thing. Let's break it down to understand what each of these things does. So first of all, this always needs to be like this. You need to create a class called Burp extender, and it needs to implement the iBurp extender interface. That is one of the interfaces in the repository of the Beaner API. You can find it there if you look for it. Now, you also need always to define at least this function. And this is the first thing that will execute when you load the extension, these register extender callbacks. And you need to do it like this. You need to pass self as always as the first argument, and then you need to have this callbacks variable. So this is populated by Burp. When Burp loads this extension, it's like it's creating an object from this class, and it's populating these values with these callbacks. These callbacks are a set of methods inside of Burp that allow us to do things like setting the extension name, things that are necessary. You need to give it a name. And also you can print some output. And finally, you exit the function with this return statement, and that's all. So this is the bare minimum that you need to run some Burp extension. Well, this is what I just showed you on my Burp. This is a list that you can find on this website, this Pursuger site, about the callback methods if you want more information. Now, this is the second demo that I have for you, and this is taken from this link that you can see on the bottom. It's from the official Pursuger repository, and it's called Hello World. So it's similar to the previous example, but now it calls some new methods, new callback methods, so some other functionality provided by Burp. So we can see that just like we were before printing to standard output, in this case we are also printing some errors. So even if there is nothing wrong with the extension, we are forcing some errors here with this get standard error. And yeah, we are printing something to it. Then we are creating some alerts, which is what you have on the main dashboard of Burp, and we are raising some runtime exception. That's something that you can do in Python when you want to force an error, even if something's not wrong, but if you want to consider a certain condition as an error, you can do it like that, and an error will happen. So let me load the second demo. I will first remove this one. Here you can see the memory usage. The more extensions that you add and that you load at the same time, the larger, of course, will be the memory usage. So it's always a good idea to only keep loaded the ones that you want to use. So here we have some output and some errors, but as we said, the errors are expected. So they look exactly as we defined them here. The output is hello output. The error, if we go to the top, is hello errors as specified here. This is the other exception that we defined on the last line, hello exception, that you can see here. And also, if you close this and go to the dashboard of Burp, there is here the alert, hello alerts. So as you can see, you can print output to different places of the Burp interface. Here I am just showing the contents of the iBurp extender interface provided by Burp so that you can see that the interface is called iBurp extender and that it only contains the method register extender callbacks, and it's a void Java method that takes as an argument these callbacks. So this shows how everything makes sense. We are implementing this extension, and inside we are implementing the register extended callbacks method, which is the only method in the interface. And as we saw previously, we need to implement every method in the interface. Since here this is the only one, it's the only one that we need to implement. That's why this is the minimum that you need for a Burp extension. If your extension is creating some output and you want it to be big, a lot of lines, then it's not a good idea to use this output window here because it doesn't hold many lines. In my experimentation, if your output is larger than, let's say, 100 or 200 lines, you can be missing some lines. And then if you are using it for debugging, you may be missing some errors and error messages and don't understand what's going on, and it's simply that it's getting lost. You're not getting the full output. So for that, I recommend to use the save to file option if you expect your output to be big and if you care about this output. Of course, you can programmatically write to a file inside the extension. You don't need to use this, but it's a simple way to redirect the output to another file. If you want to use packages from CPython in your extension that you would normally install with pip, you need to do this extra step in Jython to be able to do that, because by default pip is not intended to be used with Jython. So you need to use this module ensure pip with Jython, just like I show on the first line, and then you can install other packages and it should work. So the next demo that I will show makes use of the requests package. You can check the source code, but it's just like I'm showing here on the slide. But you will have access to all these source codes. So this one takes a little longer to run because it needs to make this external request and then receive the response from the website. It's not the fastest ever, and in fact Portswigger encourages you to use their own methods for making requests to external websites. If you want, for example, to submit something to the App Store. But here you see this output that we were waiting for from some external website, and as you can see, this is a large output, and the first line that was here, which was the version of Jython, has disappeared. This is because of this limit in the size of the output that you can have, and for that I recommend to use the save to file to avoid losing information without realizing. So yeah, this is the third demo. You can see that we are making a request to Meta. I'm getting some errors lately when I use HTTPS websites. There must be something wrong with the certificates that I still haven't figured out, but this was just to show you how you can use Python modules, but you need to make them available to Jython first. And here is where we are getting the Jython version. So this is the two pieces of output that we had. Now, let's start with some graphical elements. And the simplest, or one of the simplest, is a context menu, which is this thing that pops up when you right click on something. For that, we need to use another interface. In this case, it's called iContextMenuFactory.java. And since we are implementing it to use its functionality, as you can see on the left in the definition of the Burp extender class, we are inheriting from two different interfaces, or we are implementing two different interfaces. The iBurp extender that we always need to use, and the iContext menu factory, so that we can use context menu functionality. Then I will not go line by line explaining everything. I think it's very self-explanatory, but these create menus is the method that we need to implement of this interface, and it should return a list. We can see here on the bottom right side how the Java type for this is a list of JMenu items. So we need to return a list. As you can see here in my implementation on the left of the create menu items method, I am returning this menu list here. And this menu list, as you can see here on the third line of the method, is at first an empty array list. Array list is a Java data type, is not from Python, so we can use it from inside Python but not from inside CPython. And we start creating this menu list empty array list, and then we add some methods to it. So this add is also something that you can also do in Java with the array list type. So here we are adding a JMenu item, and later we are adding this submenu that we had defined here on the first line, which is also a JMenu. And inside the submenu here on the last line, we are adding another menu item. And you can see that inside each menu item, you have two parameters, the name of this item and the action performed. That action performed is what method is called when you click on that item in the context menu. And here we have defined these two methods. In this case, they are doing nothing, but you can put any functionality that you want in here, and it will happen every time that you click on that. Finally, well, we have this JMenu that comes, let me show you because it's not here on the slide. JMenu is an item from the Swing Java library, and Swing is a library for graphical elements, for creating graphical interfaces in Java. So we are using both the JMenu and the JMenu item. And we are also importing from java.util the array list and the list. So let's load this and see what it looks like. No errors, everything seems to be working fine. So let me generate some traffic here in the Burp history. Let me just browse for whatever and see how the history gets populated. It doesn't matter what, but we need some items. So now if we right click here, we see this extensions, and if you have not loaded any extensions, these will not be here. And we have these new menus, item, and submenu with another item. So this is what happened by us loading the extension. Now if we click in this, the first method would execute, and if we clicked on the other would execute. But since we have not implemented any logic inside, nothing is happening. So let's talk about callback helpers. These are a set of little utilities that Burp puts at our disposal and that are useful for doing very typical operations with data in the way Burp uses it. For example, when we have web traffic, it's typically encoded in base64, and if we want to see what's inside, or if we want to modify it to send it somewhere else, we need to decode it, then modify it, then to encode it again. So you get the point. And there is a lot of these to do all these little things that to do on our own would be difficult, but Burp already provides us with these methods that work exactly as Burp itself expects things. So it's a useful thing that we have. If I'm not wrong, I have another demo for this. Let me check where I use some of these callback helpers. So let's have a look at the code of that extension. Well, this is basically just loading the helpers and listing them. So it's a way with which you can explore from the inside what helper methods do we have. And well, it's not very comfortable to read like this, but you have all these things: string to bytes to string, all these things to convert formats that I told you about. So all of them are here, and if new ones have been included in the Montoya API, you can probably get them doing something similar to this. All right, let's continue. Yeah, okay. There is this particular method here that is very useful for everything that involves clicking elements on the Burp history and doing things to them, etc. You need to use this one that I have marked in here. So you can forget about the rest, but this one is very useful and you will probably be using it on your own extensions. So it's what is, for example, used when you click on send to intruder to a request. These type of things. It checks which ones you have selected from a list and then returns to you handlers for those selected items. And these things that you see in the Burp history list are objects of the iHTTP request response type. You can see here, for example, in the get proxy history, how it says it returns a list of objects of this type. This is the Java way of saying that this is a list with these square brackets behind the data type. And inside each of these elements, you have a set of things inside. So you have the request, the response, and things like the comment that you can write on the Burp history or the highlighting, etc. So you have access to all the properties of these objects, which are the history elements. Sorry, I'm not sure. Yeah. So you can think of these history elements exactly as objects like the ones we discussed before from object-oriented programming. They are exactly that. They are containers with properties and methods inside. And it's very typical from object-oriented programming when you have things that get dynamically created or destroyed. Like in this case, every time we browse a website, we get a bunch of new uh, history objects. Yeah, so this is the method that you can use, the callback method provided by Burp, to get a list of all the history methods. Again, this is very useful for your own extensions. Alright, I have another demo here. I'm gonna load it first. And let's check its source code. Alright, this is already a bit larger, but no problem. As always, we are implementing from the iBurp extender method and then from the iContext menu factory to have access to this possibility of using context menus. In here, I am creating 4 submenus with these names, and each of them will call each of these functions or methods that we have here, and all of them are very similar. So one is returning the hosts of the selected elements, and the next one is returning the protocol, and then the body of the request and the body of the response. Or the contents, I'm not sure if it includes the headers, we will see now. What is important to realize is that each of these things is a list, because it enables us to select many elements from the list and apply the same thing for each of them. So here we are saving this list to this variable, and here we are iterating inside a loop through all of these and do something to each of them. So let's see that in action. It loaded without errors, and we need to do the same thing as before. We can select a bunch of these things. Here we have, and click get hosts. So if now we go to the extension, we see the hosts of the selected messages, 3 of them Google and then these other G static. We can check once again that is the ones that we selected here on the hosts column. Now let's try something different. Let's see the protocols. So we have here the protocol, all of them use HTTPS. Next, requests. So now here we have the request, and yeah, it includes the headers of each of them. So we have here another one, then another one, etc. You can get all the contents of the request, and in this case they are get requests, so of course they don't have any body inside. I'm not sure if any of those was a post one. Yeah, so let's see. Maybe it's just that the output is too large, and we have a post request, but apparently it doesn't contain any body. Or maybe we need to do something different to get it. That's not a problem right now. And finally, we have the responses. So yeah, as you can see, we have regular responses here. Good. So now we know how to retrieve elements from the Burp history and get things from inside of them. If you look here, I must be applying somewhere bytes to strings. Yeah, because to save some space, it's using a bytes object for the request and the response. So we need to use this helper method to convert convert it to something that we can read on plain text. Now, let's start adding more graphic elements. So we all know extensions that have a tab. It creates a new tab when you run it. And for that, let's check the next demo. Alright, so here you see that it created this new tab, although at the moment it's empty, but we will take care of that later. For the moment, let's see what's inside. So in this case, as always, we inherit from Burp extender, but we also inherit from iTab. This is another interface that the Burp API gives us to create new tabs. So if we were to look, here at the definition of the iTab interface, we see two methods that we need to implement. The get tab caption, that's the name that will appear on the tab, and then get UI component, where you would define what's inside of that tab. And at the moment we are defining nothing, so it's empty. So here you can see the code. We give here the name to that tab, and then we just say that this is going to be an empty panel, a JPanel, another Java Swing element. All right. So, okay, if we start to add graphic elements, we may want just to make it prettier, or for some functionality that it has things like colors, bold faces, bold types, italics, all that. That is done in Swing using HTML attributes like fonts with different properties like the color, etc. At some point, Porswigger made some change and disabled that HTML rendering because of some apparent security reasons. It's explained here in the forum, and that requires some additional changes that you need to do to disable that globally enabled rejection of HTML rendering for the elements that you want HTML rendering. It stopped my workflow for a long time in my own extension. It broke it completely because at some point everything looked super bad. In my extension there are many colors and things that are highlighted and some symbols, and one day I opened the extension and all of it was gone, and things were where they shouldn't be, and everything was looking very weird. And it took me a very long time to figure out that this was happening and how to fix it. There are some things that are easily fixed, like the labels. You need to create a label and then do this: put client property html.disable equal to none. Then it will not disable HTML rendering for that element. But other things, especially tables and cells inside tables, are much more complicated. And also elements which have different properties, like a button which can have text in one color and background in another color, require that you tweak each of them individually, and that's what I'm showing you here. So if you ever need this, know that it exists, but it's not so easy to find. So I encourage you to come here to check once again, but I will not spend more time on it. Okay, so I I skipped in the slides my last demo for today, but it's one where you will see how to implement or to add more graphic elements and to have something that looks like the extensions that all of us are used to. So it's demo tab 2. It's the same thing as before, but now including some elements. So here we have a button on the top, a text box on the left where you can write something, and you can see it here. And we have a list from which you can select elements or several lines at the same time. And we have this slider where you can put things on one side or on another, and you can resize it. So let me show you the source code and briefly discuss what's inside, because this one's larger and you now have all you need to know to understand it yourself. This looks similar to the one before, and here, yeah, I didn't show you, but if you click the button, the text in this text field will change to test 123. So we can click the button and see how it changed. So we have this method to do that, set text of the text field. The text field is another object that we have defined somewhere, and you can find it here. All these things are preceded by self because they are part of the object. The object in this case is the extension itself that has been instantiated by Burp. Here, well, this is the get UI component where we need to implement all the things from the Swing library that we want to appear on the panel. So we have the panel itself. This border layout, there are different types of layouts that arrange things in different ways. You can explore it, it's a bit more complex. And we have another panel with a different layout. So then we have this split pane, which is this slider that you can move to the left or to the right. You here select where it's at first, so it always appears at the same distance from the edge. And here you indicate that it's a horizontal split. You can also say vertical split, and then you could resize it up or down. Then we have the table with these contents that we have here. And for some reason, the column names are not showing, but they should. So I'm not really sure what's going on there. If you want a table, you need to define the table on the one hand and the data model on the other, and then here pass the data model to the table. So the data model is basically the data that we have here as a list of lists. You can check that with more slowly yourself. But yeah, as you can see, it can be intimidating at first, but everything makes sense. Once you start putting some elements and playing around with it, it becomes much simpler. So that's it. That's the most complex extension that I have. So I just wanted to finish by giving some tips from my own experience with submitting extensions to the Burp B App Store. So first of all, you will need to ask yourself, is there really no other way of doing what you want to do than creating an extension yourself? Isn't there an extension that does what you want already or something similar that you can adapt? Or do you really need an extension for that? Maybe you could export the traffic and do it outside of Burp. Maybe that would be simpler. But again, it's cool to have your own extension published. So if you want to do it, go ahead, by all means. Um, First of all, make sure that it works. You can create some tests even if you want, but it's not necessary. I didn't include any tests in my extension, but still Portswigger accepted it without them. But I made sure that everything worked, and I had to fix a lot of mistakes and errors and things that Portswigger itself changed and screwed up the normal flow of the extension. So yeah, it wasn't easy. It took a long time to do and to figure out all these things on my own. I hope that now with this tutorial things are simpler for you guys. What could be actually the main blocker when submitting extensions to them is if you use native functions of the language that you choose instead of using the Burp APIs to do some things. So in my extension, there was some functionality that I in the end removed, but it was making requests to my own GitHub repository where I was planning to upload some things from time to time so that they could be picked up by people's burps. But I was using the requests library from Burp, and they told me to use instead one of theirs, and it was very complex to use, so it wasn't worth it. The functionality was not very important, and I ended up discarding it. But be mindful of that. They could make you spend some time doing this kind of thing, so it could be better to ask them in advance if you can use a certain function before they turn down your um, extension and you need to spend more time redoing things. Just keep that in mind. Other than that, I have nothing else to share with you today. I just wanted to say that I hope this was helpful, and if any of you guys had in mind creating some extension, now you know where to start. I still encourage to use the old API, but if you want to try the new one, go ahead. But you will see that this presentation is not super useful. Um, if you have questions, feel free to talk to me on LinkedIn or on Telegram. Here are my. I'm sorry that the LinkedIn one is in 2 lines, but it should be only one line. Feel free to connect with me and ask any questions over there. I will try to answer them as well as I can. Although I did this extension some time ago, but yeah, once you understand the concepts, it's not so difficult. And here in this site on my GitHub repo, you can find all the demos that I have been showing, and you can play around with them and feel free to use them or modify them. No license problems nor restrictions. So that's all for me. Thanks again for your attention, and I hope to talk to you soon. Goodbye.